Today I am going to explain the flip-flop. So in this I am going to take an AJK flip-flop, and similarly the simulation is done for an and for SR flip-flop, T flip-flop and a D flip-flop, and the output is checked with respect to the inputs what we are going to provide for the test bench. And the JK flip-flop are used to determine unpredicted states of an SR flip-flop or an RS flip-flop. The J and K inputs are analogous to the SR flip-flop. The problem of what to do when SR are asserted simultaneously is solved using an JK flip-flop. Inputs J and K behaves like an inputs S and R to set and reset the flip-flops respectively. J asserts the master's S input only if the flip-flop Qn output is currently 1, that is Q is equal to 0, and K asserts the master R input only if Q is currently 1. Thus, if J and K are asserted simultaneously, the flip-flop goes to the opposite of its current state. That is, when the J and K both are having an high inputs, that is J equals to 1 and K is equal to 1, the output of that state will be an inverted, or that state what we call as an toggle state. So let us now see to the block diagram of the JK flip-flop, where J and K are the two inputs. I have considered an RS T, which is an reset and along with a clock which is continuously provided to the JK flip-flop with then two outputs Q and Q bar. Now let us look at the two table, and later we will see the how the Verilog code is done. In a two table, whenever the reset is 1, the clock is high, whatever the condition of the J, that will be output will be previous state, so there will be no changes in the output. When the reset is 0 and when the clock is high, that is at the positive edge of the clock, when the condition J and K both are 0 0, the previous output what is initialized will be follow the same. When again keeping then reset as an 0 and clock in an high, and the condition is given as J is equal to 0 and K is equal to 1, the output state is 0 1, which is an reset state. Then when a clock is 0 while keeping an reset is equal to 0 and clock is high, J and K are 1 and 0, the output is 1 0, that state is called set state. And last is when the clock is high with respect to the reset is equal to 0, both the J and K inputs are high, the output state will be toggle in condition, which means that when the previous output is 1 0, when I give the condition J is equal to 1 and K is equal to 1, for that condition the output will be 0 1. And again if you are going to provide the same inputs, that is J and K is equal to 1, then the output will be 1 0. So this condition is called as a toggle condition. Now let us see the how to write an Verilog code. So here I am going to consider J and K are the variables of an input, clock, reset, Q and Q bar. I am going to define in this the clock, reset and J and K are the inputs. So I have defined that clock, JK and reset are an input and output are Q and Q bar. And I want to check at every rising edge of the clock. So for that I am going to consider always at the positive edge of the clock, I need to check if the reset is 0 or reset is 1. If the reset is 0, then q is equal to 0 and q bar is equal to 1. If the reset is 1, then q is equal to 0, q bar is equal to 1, and if reset is equal to 0, then it will go for an case statement. You can write by using an case, or you can write by using an if, whatever the logic, whatever the statements. I am going to use a case statement. When an jk, I am considering jk as a single variable, and I am assuming that jk is equal to 0 0, the previous state is going to be executed. When the condition of jk is 0 1, the output will be 0 1, and when the condition of jk is 1 0, the output is 1 0, and when the condition of jk is 1 1, the output will be toggle condition. So this is a program. Now let us see how to run the same program by using a Xilinx software. So open the Xilinx software. If any of the previous program is run, please close that. And now create a new project. Give the project name, and this is an optional. You can store anywhere. The project name is an optional. You can give any of the name, and be ensure that is the preferred language is Verilog and the simulator is ISE, and along with that please verify with the family, device and the packages and the speed. Now I am going to create a new source. In that I am interested in an Verilog module. Select the Verilog module, give it as an F file name, that is the module name, jk_ff. Next, and give which are the inputs and which are the outputs. Next, finish that. It will ask, do you want to create it? Yes. Next, and it is asking to exist any of the wave. No, there is no need to add any of the other projects, and finish off. So this will creates my own project of a JK flip-flop, whichever I have done. So already I have copied the program. I will paste the same program here. And save the program and go to file and save once again and select that. Now I will check for an if there any error occurs. So there is no error in my program. Then I will go for an how to dump. Before that I am going to show the simulation, and I will verify with the functionality of a JK flip-flop with respect to the truth diagram. So to that I am going to create a one more source, which is right click, add a new source, right click, new source. In that I am going to check the waveform. I will give as j_k_. Next, finish. A waveform wizard will be open, that is initializing the time. In that select the single clock which is left further than clock itself, and say finish. So according to my program, when the output has to be exit when the reset is 0. For that condition I need to make that while giving an waveform. I will make for an 0 condition and again for an 1 condition. So that means whenever I have an 0, reset is equal to 0, the output should be obtained. Whenever the reset is 1, the output should be follows the same. So next I am going to define a JK, all the condition. First it will take given as an 1 0. Next 0 0 which is an unchanged condition, and again 1 1 which is a toggle condition, and 0 1, and again I will give an 1 1. Now we will save this waveform and then close this window. Now select the test bench. In that, be ensure that the source for the simulation behavior simulation has to be selected, and go for an Xilinx simulator, stimulate the behavior model. So here, due to the internal clock generation, you will have the period and the duty cycle. You can neglect that, or you can simply keep that, or here I am going to delete that. That is not needed for me. Delete. Once again delete, and I will rearrange this thing. First is an clock, second is an reset, and next is an inputs, and then the output. Now let us check. So this is the first which has been predefined by the internal clock itself. The condition is 0 0, it is an X state. Next, as in my program, whenever the reset is 0 and whenever the clock is 0, when the conditions are 1 0, the output is 1 0. Fine. Next, again similarly, whenever the clock is I and whenever the reset is 0, the output of the condition is 0 0, so that remains, it has to no change, so it remains the same, that is it follows the previous output. Next, what I am going to see, whenever the reset is 0, whenever the reset is 1 and clock is 1, the output is 1 1, it has to get toggle, so 0 means it will be an 1. Whenever reset is 0 0 1 condition, 0 0. Now let me see how to dump the code into the FPGA kit. Go for an implementation part. In this, select the user constraints and give which are the input pins, that is an OLED that we are going to use, that will be given by the FPGA manual. For JK I am going to select an pin 21. For JK is equal to 1, pin 21. Similarly for JK is equal to 2, I am going to select for an 27. When the clock is 1, I will select the clock as an pin 143. And for an reset, I am going to select 138. The output pin is driven at pin 20 and pin 26. So now save the file. It will ask whether to save in a Verilog default. Yes, okay. Then close that. Now run the configure target device. Now it will check for all the implementation, that is for a translation, mapping, place and route, generated bit files, and later it will configure the target device.